helpful, please like, subscribe, and press the bell icon for notifications. So today we will be learning about the determinant of a matrix. And a matrix, as we know that, is an array of numbers enclosed in square brackets. And here are a few examples of matrices, and there are all different kinds. So these two matrices are called rectangular matrix. This with one row is called row matrix, and with one column matrix, and square matrix where rows and columns are equal. So a rectangular matrix are of order n times m, row matrix is order of 1 times m, and column matrix order of n times 1, and a square matrix n times n, or here in this case 3 times 3. Now the determinant is associated with square matrix. So it is a scalar value of square matrix, and it is denoted by two parallel vertical lines and written as DETA in brackets, or just simply DETA. Now if A be any square matrix with elements A, B, C, D of order 2 by 2, then its determinant will be determinant of A is equal to determinant of A, B, C, D. Then we cross multiply first A with D and then minus C times B, and we will get some scalar quantity here. Now let's take an example for 2 by 2 matrix. If A is equals to 1, 2, 3, 4, then determinant of A is multiply diagonally 1 by 4, then minus diagonally 3 times 2, we will get 4 minus 6, that is minus 2. Therefore, determinant of A is minus 2. Now note that this is not modulus. This sign is not for modulus, but it is determinant. Therefore, negative 2 will remain negative. Sign will not change here. Now for the determinant of 3 by 3 matrix A, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. So we need to first understand minor and cofactor, because these two terms are going to play an important role in finding the value of determinant of matrix A. So now let's talk about the minor first. So minor is denoted by capital Mij, where we eliminate ith row and jth column and then write down the remaining elements as 2 by 2 matrix form, and then find out the determinant. Now let's find out the minor for A21, that is element in second row and first column. So let's first eliminate second row and first column and write down remaining 4 elements, that is A12, A13, A32, A33 in 2 by 2 form, and then cross multiply A12 by A33 minus A32 times A13, which will give us some scalar quantity. Now let's take a matrix 1, 2, 3, 4, 1, 1, 2, 2, 1 and find out minor for 4, that is M21, because 4 is in second row and first column. So to do that, let's first eliminate second row and first column and write down remaining 4 elements, that are 2, 3, 2, 1 in 2 by 2 form. So that is 2, 3, 2, 1, and now multiply 2 by 1 minus 2 by 3, which will give us 2 minus 6, that is minus 4. Similarly, we can find out minor for 1, that is in third row and third column. So M33 for 1. So cross out third row and third column here, and our 4 remaining elements will be 1, 2, 4, 1. Now multiply 1 with 1 minus 4 times 2, that is 1 minus 8 is equal minus 7. Therefore, to find the minor for an element in ith row and jth column, we eliminate ith row and jth column and then write down the remaining elements in 2 by 2 form and then proceed as we do in 2 by 2 matrix. Now let's talk about the cofactor for matrix A, that is A11, A12, A13, A21, A22, A23, A31, A32, A33. So a cofactor is denoted by capital letter Aij. Now cofactor Aij for each element can be found out by multiplying minus 1 to the power I plus j with minor of that element. For example, let's find out cofactor of the element A11, that is element in first row and first column. So here I is equals to 1 and j is equals to 1. So A11 will be minus 1 to the power 1 plus 1. Now for M11, eliminate first row and first column and write down the remaining 4 elements, and these are A22, A23, A32, A33. Now the value for minus 1 to the power 2 is plus 1. So we just cross multiply A22 with A33 minus A32 with A23 and we will get some scalar quantity. Similarly, we can find out the cofactor of A23, that is element in second row and third column. So A23 is equal minus 1 to the power 2 plus 3. So eliminate second row and third column, and the remaining 4 elements are A11, A12, A31, A32. Now minus 1 to the power 2 plus 3 will give us minus 1. Therefore, minus times cross multiply A11 with A32 and then minus A31 times A12, and here also we will get some scalar quantity. So in any 3 by 3 square matrix A11, A12, A13, A21, A22, A23, A31, A32, A33. Sign for element A11 is minus 1 to the power 1 plus 1. For A12, it's minus 1 to the power 1 plus 2. For A13, it's minus 1 to the power 1 plus 3. Similarly, for A21, it's minus 1 to the power 2 plus 1, then 2 plus 2, then 2 plus 3, then 3 plus 1, 3 plus 2, and 3 plus 3. So, as we can see, all even powers will give us plus 1 and all the odd powers will give us minus 1 here. So we will get 1 minus 1, 1, minus 1, 1 minus 1, 1 minus 1, 1, or simply plus minus plus, minus plus minus, plus minus plus. So if I plus j is even, value for minus 1 to the power I plus j is plus 1, otherwise it's minus 1. So if we remember this, then we don't need to write minus 1 to the power I plus j every time we need to find cofactor of any element in the matrix. Now let's find out the determinant of A, that is 1, 2, 3, 4, 1, 1, 2, 2, 1. So the determinant of A can be found out by adding product of Aij and the cofactor of Aij, that is capital Aij, along any row or any column, where Aij is an element in ith row and jth column and capital Aij is the cofactor of that element. So as we can expand it along any row or column, let's expand it along first row, whose elements are 1, 2 and 3. Therefore, determinant of A is equal A11 times cofactor of A11 plus A12 times cofactor of 12 plus A13 times cofactor of A13. Now the first element in first row is 1, that is A11 is 1, similarly A12 is 2, A13 is 3. Therefore, 1 times cofactor of 1 is minus 1 to the power 1 plus 1 minor of A11 plus 2 times cofactor of A12 is minus 1 to the power 1 plus 2 and M12 plus 3 minus 1 to the power 1 plus 3 and minor of A13. Now, to find the value of minor, let's first eliminate first row and first column and write down the remaining 4 elements, and these are 1, 1, 2, 1. Now plus 2 and minus 1 to the power 1 plus 2 will give us minus 1, and here eliminate first row and second column and write down the remaining 4 elements, and these elements are 4, 1, 2, 1. Similarly, here we will get 3 times 1 and minor 1, 3 will be eliminate first row and third column, and the remaining 4 elements will be 4, 1, 2, 2, which will give us 1 times 1 is 1, so just cross multiply, we will get 1 minus 2, and this will give us minus 2. Then 4 times 1 and minus 2 times 1. Similarly, this will give us 3 times 4 times 2 is 8 minus 2. Therefore, minus 1 minus 4 plus 18, that is 13. Therefore, determinant of A is 13. Similarly, we can expand the same matrix along any column. So let's take second column, and the matrix is A is equal 1 2 3 4 1 1 2 2 1, and the elements of second column are 2 1 2. Therefore, determinant of A is equal A1 2 times cofactor of A12 plus A22 cofactor of A22 plus A32 times cofactor of A32. Now, the values for A12, A22 and A32 are 2, 1, 2 respectively. Therefore, determinant of A is 2 times cofactor of 2 is minus 1 to the power 1 plus 2 times M12 plus 1 times minus 1 to the power 2 plus 2 M22 minor of second row and second column plus 2 times minus 1 to the power 3 plus 2 M32. So minus 1 to the power 1 plus 3 will give us minus 1, and this will give us plus 1, and this minus 1 because of the even and the odd powers. Now for minor 1 2, let's eliminate first row and second column and write down the 4 remaining elements. Similarly, for M22, eliminates second row and second column, and the remaining 4 elements are 1 3 2 1. Now similarly for M32, eliminate third row and second column, and remaining 4 elements are 1 3 4 1. Now 2 times minus 1 is minus 2, and cross multiply will give us 4 minus 2, and here 1 minus 6, then minus 2 times 1 minus 12, which will give us minus 2 times 2 minus 5 minus 2 times minus 11, that is minus 4 minus 5 plus 22, that is equal to 13. Therefore, determinant of A is equals to 13. So we can expand it along any row or any column, and the value of its determinant will remain the same. In our next topic, we will be covering first and second property of determinant. Thanks for watching.